So today we're going to look at one of the problems at the MIT 2023 Integration B semifinal. We'll begin with problem 1 today, and that is the indefinite integral of e to the power cosine x times cosine 2x plus sine x. The sine x is inside the cosine function. So it's a very interesting problem. So the first thing that I personally would do is to expand the cosine 2x plus sine x term. And that using the sum of angles within the cosine function, identity would be now cosine 2x times cosine sine x minus sine 2x times sine x. Now expanding out cosine 2x term now results into cosine squared x minus sine squared x times the cosine sine x minus, again expanding sine 2x term to 2 sine x cosine x times sine x. And then obviously just collecting like terms, so we have cosine squared x cosine sine x minus sine squared x cosine sine x minus sine x cosine x sine x. Now looking at the entire integrand in entirety, e to the power cosine x times cosine 2x plus sine x is equals to e to the power cosine x, again bringing down this equation, cosine squared x cosine sine x minus e cosine x sine squared x cosine sine x minus 2 cosine x sine x cosine x sine x. Now I could spread out these times 2 time here, so that one of the negative e cosine sine x cosine x is attached to the first term, and then the remaining would be attached to the second term here as follows. And you'll see why this will become relevant in the next step, as shown here. So the next thing that I would want to do is to factor out one of the cosines in the first term, and then obviously the cosine x term in the second term as follows. So we have cosine x outside times e to the power cosine x cosine sine x minus e cosine x sine sine x. And then in the second combination, I would factor out sine x, so that I'm left inside the bracket with e cosine x cosine sine x. Now I have mixed the sine x term here from the sine squared x. So the equation from the previous expression now allows us to do a couple of things. The first thing that we can do is we can look at this first term here. And this first term here is the same as e to the power cosine x times the derivative of sine x. So when you derive sine x, you get first cosine of sine x times the derivative of sine x, which is cosine x. And then when you look at the second term here, it's the same as sine x times the derivative of e to the power cosine x, which is obviously e to the power cosine x times the derivative of cosine x, which is minus sine x. And then when we look at this term here, this is also the same as cosine sine x times the derivative of e to the power cosine x. And the last term there is the same as e to the power cosine x times the derivative of cosine sine x. And so looking at this term here, these two terms, what we can see here is that they are the same as the derivative using the product rule of cosine sine x times sine x. And again, these two terms also is the same as the derivative of e to the power cosine x times cosine sine x. Product rule that allows you to sum up the derivative of each component of a product. Now this allows us now to express this previous expression as cosine x times the derivative of e to the power cosine x times sine x, and then the second plus sine x times the derivative of e cosine x cosine sine x. Then moving on further, we can write this term here. Then we can add e cosine sine x, cosine sine x times the derivative of cosine x, trying to interact with this first term here. And then the second thing we could also do is add e cosine x cosine sine x times the derivative of this sine x here. And then in order to cancel out this term, we subtract this value here. The derivative of cosine x is minus sine x, so we subtract that component. And again, for the second added term here, we subtract e cosine x cosine sine x cosine x, where the derivative of sine x is cosine x. So this allows us to now do a couple of things. Now, because we have the derivative of e cosine x sine x, and then we also have the derivative of cosine x. This again allows us to take advantage of the product rule in differentiating terms. So this now becomes the derivative of e cosine x sine x cosine x plus e cosine x cosine sine x sine x. So we have a product rule of this term and the cosine term covered by this and this. And then in this second term, we have this product here covered by this and that. Now, this remaining value here now is brought at the end here. Then what we can do next, looking at this residue here, we see that this is also the same as sine x times the derivative of e to the power cosine x. And the blue term here is the same as e to the power cosine x times the derivative of sine x. Again, taking advantage of the product rule. And so now what that allows us to do is the term here in the first position remains the same, but this 2 now is the same as the derivative of e to the power cosine x times sine x. So eventually now we have the derivative of this first term minus e cosine sine x, right? Now this first term here, as you can see, using the sine of two angles, the sum of two angles, is the same as sine x, this x here, plus the sine x. Now going further down, so we have the expression of the integrand is the same as the derivative of e to the power cosine x, sine x plus sine x minus sine x. So plugging this into the original integral, where we say it is the integral e to the power cosine x cosine 2x plus sine x, it's the same as the integral of the derivative of e cosine x plus sine x plus, of cosine x plus sine x minus sine x. So eventually what the answer of this integral is, it's just e to the power cosine x, sine x plus sine x minus sine x plus a constant. of a value that we may not know. So this is the solution of this problem. It's a little bit windy, um, and it takes us away from some of the tools that we're used to in solving integrals, but by keenly observing how these values show up, you can easily find the solution. Thank you again for joining us tonight or today with this solution. For those of you who have not subscribed to our channel, I really encourage you to subscribe to our channel and to just go with us in this journey of solving these very interesting and complicated problems. Thank you.